You know, I was thinking the other day about looking up at the stars. It's really like looking back in time, isn't it? You're not
Mm.
seeing things as they are now, but getting these, well, messages from the past. And today we've got one from way back.
Yeah, this one was sent when the universe was, what, barely 1.6 billion years old. It comes from an object called APM 08279 plus 5255. It's this incredibly distant object they first spotted back in 1998, I think, in the constellation Lynx.
And it made a splash because, initially at least, it looked like the most luminous thing anyone had ever seen.
Yeah.
Just unbelievably bright.
Right, that was the headline.
So what we want to do today is quickly unpack why it looks so bright, because that initial idea was a bit off, and what this thing actually is, because, well, the reality is maybe even more extreme.
Okay, yeah. So the first big piece of the puzzle, the reason for that incredible brightness, is something called gravitational lensing. Basically, there's a galaxy sitting almost directly between us and APM 08279 plus 5255.
And it acts like a magnifying glass, like a cosmic telescope.
Exactly. It bends the light from the object behind it, making it appear much brighter to us here on Earth.
And the first estimates for that magnification were, well, they were huge, weren't they? Something like 40 to 90 times brighter.
Yeah, initially that's what the numbers suggested, which, would make it unbelievably luminous intrinsically. But once they got better data, looked across different wavelengths, ran more complex models,
Right.
they revised that magnification way down. It's now thought to be closer to maybe 4 times magnification, still significant, but not 90.
Okay, 4 times is a lot different from 90 times. How did they figure that out? What changed?
Well, it came down to the details of the lensing itself. When they got a really sharp look with the Hubble Space Telescope, they didn't just see one bright spot. They saw the quasar was split into 3 distinct images.
3. Isn't that odd? I thought lensing usually gave you 2 images, or maybe 4.
Exactly. 2 or 4 is typical for, a relatively simple symmetric lens. Seeing 3 means the foreground galaxy, the lens itself, must be more complex. It's not perfectly smooth. So modeling that complexity, figuring out how an uneven galaxy could produce those 3 specific images led to that much lower overall magnification estimate of about 4x.
Got it. So the weird image count helped refine the magnification. Okay, let's talk about the object itself then. APM 08279 plus 5255. It's a quasar, right? An active galactic nucleus, or AGN, in a giant galaxy.
That's right. It's basically a huge elliptical galaxy, and at its heart is, well, an engine, an AGN powered by a supermassive black hole.
And when we say supermassive,
We mean really supermassive, especially for that early in the universe. The estimates are pretty staggering, somewhere between 10 billion and maybe even 23 billion times the mass of our sun.
10 to 23 billion? That's enormous.
It's huge, and it's actively feeding. There's an accretion disk of materials swirling into it, and this whole central engine, probably surrounded by a big dusty torus, seems to be pointed almost face-on towards us.
Okay, but modeling something like that, I mean, a lopsided lens galaxy, figuring out the distance, and estimating the mass of a black hole 12 billion light years away, that requires some serious computing power, right? Really sophisticated modeling. Speaking of needing cutting-edge help with complex systems, this segment is sponsored by Embersilk. If you need assistance with AI training, advanced automation, or even just uncovering where AI agents could make the most impact for your business or maybe your personal life, you should check out embersilk.com for all your AI needs.
Right, good point. And getting back to this amazing object, APM 08279 plus 5255. It's not just an AGN. It's also classified as what's called a ULIRG.
A ULIRG.
What's that? Ultra-luminous infrared galaxy. It basically means that even taking the lensing away, even at its intrinsic brightness, it's still incredibly luminous, especially in infrared light. It pumps out energy across pretty much the entire spectrum.
Okay, ultraluminous, giant black hole, complex lensing.
Yeah.
But here's the part that just, well, it floored me when I read about it. Water.
Ah, yes. The water.
Apparently, observations found that this quasar contains the largest single mass of water ever detected anywhere in the universe. Is that right?
That's correct. Based on observations, particularly from the Caltech submillimeter observatory, they detected the signature of water vapor.
But how? I mean, how do you even see water vapor from 12 billion light years away?
You look for its spectral fingerprint. Water molecules absorb and emit radiation at very specific wavelength frequencies. So by analyzing the light coming from the quasar's vicinity, especially the radiation from hot gas and dust, they could identify that characteristic signature of H2O. And the amount is difficult to wrap your head around.
How much are we talking about?
The estimates are something like 100 trillion times the amount of water in all of Earth's oceans combined.
100 trillion. That's just unbelievable.
Yeah.
All this water vapor in this one object.
Circulating in that region, yes, it's an enormous reservoir.
Okay, so why does this matter? Why should you, listening right now, care about water vapor in a galaxy far, far away and long, long ago?
Well, think about when this water existed. The light, the radiation carrying that water signature, left APM 08279 plus 5255 only 1.6 billion years after the Big Bang.
So very early in cosmic history.
Exactly. We knew water, H2O, could form early on. Oxygen was produced in the first massive stars, hydrogen was everywhere. But finding this much water, this massive quantity, so incredibly early, it confirms that the basic ingredients for chemistry, for potentially complex molecules, maybe even life eventually, weren't rare. They were widespread, pervasive, right from the universe's early stages. Water was abundant.
Yeah, it's incredible. So this one object, highlighted by a chance alignment causing this cosmic magnifying glass effect, showed us one of the biggest black holes and the biggest water reservoir known, both from the universe's youth.
Yeah, it's a remarkable confluence of discoveries from a single source.
It really makes you stop and think, doesn't it? What are the things, basic elements or compounds that we kind of assumed took a long time to become common? What else was actually abundant way back near the beginning?
That's the fascinating question, isn't it? What else is hiding in plain sight in the light from the early universe?
Absolutely. Well, if thinking about that resonates with you, and you enjoyed this deep dive into a truly extreme cosmic object, please subscribe to the show wherever you get your audio. Hey, and maybe leave us a 5-star review if you can. It really does help get the word out about the show. Thanks so much for tuning in.